Hello everyone, welcome to my channel Ritu's vlog, and today I'm here with a new video. I'm a student nurse. I'm studying second year recently, and I'm making videos all about nursing. When I was enrolled in the nursing and I was looking for a lot of videos, I didn't found that kind of video what I'm looking for. So I am making video that I feel like this need to be in my YouTube channel. So I'm planning to make on that one. So if you want to enjoy a journey with me, then don't forget to subscribe my YouTube channel, and let's be a friend and work together and helping hands with each other. So today we are talking about dose calculation. Guys, I am super nervous when it comes about math. I'm so bad on mathematics, so I hate math actually. But dose calculation is not that bad, guys. If I can do it, you can do it. Just you need to make a practice. Today I'm going to talk you about what I learned in my first year about dose calculations. So after that I will teach you. We are doing dose calculations in second year as well in IB. So I will teach you everything what I learned from our class to make you more compatible and helpful before you going to the nursing school, or if you are in nursing school it will be helpful maybe. Let's see. Okay, then let's turn to our topic, dose calculations. At first I want to talk you about dose calculations like metric conversions. Metric conversion when it comes like kg, gram, milligram and micrograms. So you need to remember all the things, and also you need to remember all the abbreviations. In first year they will ask you all the abbreviations and metric conversions. I will show you how to do that. Sorry guys, this is for my baby whiteboard, so it's so messy here. So I will explain you what we gonna learn today. Like first we need to convert from one unit to another like this. First of all, kg to gram, we need to multiply by 1000. Kg to gram we need to multiply by 1000. So when we go with gram to milligram, we need to same multiply by 1000. And when we go through milligram to microgram, we need to multiply by 1000. When we going from big amount to a small amount like kg to gram and milligram and the microgram, we need to do multiply. When we going from big amount to a smaller one like kg to gram and gram to milligram and milligram to microgram, we need to do multiply. When we going down, we need to do multiply. Same things it's happen when you are doing divide. Like when you are going to mcg, microgram to milligram, we need to divide by 1000. When you're going mg to gram, we need to divide by 1000. When we going gram to kilogram, we need to divide by 1000. So when you go from smaller to higher one, you need to always divide by 1000. And when you go bigger to smaller, you need to multiply. I think it's make clear to you. Let's see this one. I have a here 0.03 gram. This is on gram. We need to convert this in mg. Then gram is the biggest one, then mg. So we need to multiply by 1000. When you multiply by 1000, it comes 30 mg. The other one is 1740 gram, 1740 gram to kilogram. Gram is the smallest one and the kilogram is the biggest one. So we need to divide here because it's going up. 1.74. Next one we have 97 mg. Divide in grams because here is a grams. And the answer will be 0.097. And the next one is 170 mcg is equal to mg. mcg is the lowest one, so we need to go up. So we need to divide, and the answer will be 0.17. Now we are going to talk about tablet calculation. Sorry, my handwriting is not so good. And it's so tablet. When we are doing tablet calculations, we need first required dose, by stock dose is equal to number of tablet. Sorry, this board is so small. So required dose means the amount what the doctor prescribe, and the stock is what we have in the store. So required dose means doctor prescribe for us for the medications, and we have stock in our backup store. The stock dose is that one. So always prescribed dose from the doctor is up, and the store where the stock dose should be in down part. So this equal to number of tablet. Let's see, I have one questions. Let's try that one. So for the tablet calculations, I have a question here. Always remember the prescribed doctor orders should be in the top, and the stock dose and number of tablet to administrate. So let's see the question. The health consumer is ordered oral selegiline 2.5 mg for Parkinson's disease. You have available 5 mg saline tablet. How many tablet will you give? Let's see here. 2.5 mg is what is this one? It ordered oral selegiline is 2.5 is ordered by the doctor, so it should be on top. 2.5 mg. And what's this is a required dose, and the down below there is a you have available 5 mg saline tablet. We have available, which means stock, which is 5 mg. Now we need to divide 2.5 mg divide by 5. It comes, I have a calculator here, so 2.5 divide by 5 is equal to 0.5. Answer is 0.5 tablet. I hope you understand. The next one is volume calculations. Volume which comes in the liquid one. So this one before we have done for the tablet, now this is for the volume one. The volume calculations is the same, normally the same, but you need to add here stock volume. Upper the required dose what doctor prescribe and the stock dose what's in our store into stock volume means what is the volume of that whole medications. So scale to what the answer you need to figure out. We can practice one questions. So here is a question for volume calculations. Your patient is prescribed a stack dose of 300 mg gentamicin 8/1230. The stock solution is 80 mg in 2 ml. What volume of medication do you require? Then we can see here the prescribed word, and the doctor is prescribed 300 mg. So our required dose is 300 mg. And what the stock? Now we are looking for the stock dose. The stock dose is, the stock solution is 80 mg. Then we are writing this here 80 mg and in 2 ml. It says here the volume is 2 ml. So we multiplying and putting 2 over here. We need to calculate. All the things are in good order, so we don't need to anything like there is mg and mg. If there is a different, then we need to multiply or divide something. But here is a mg and mg, so we don't need to change anything. So here is my calculator. We are following this one. Required dose stock by stock dose into stock volume and volume to be given stock dose. Let's see the calculator. So I'm always using calculators. So if you are good in math, so you can use your brain into 2, which is, it's came here 7.5. Then the answer is 7.5 ml. Now we are talking about intravenous flow rate, which is ml hour. And this is the things when we administering intravenous fluid by volumetric pump. You must first calculate the rate at which the fluid are to be given in ml per hour. So the formula is required volume, which should be in ml, and the time in hour. In intravenous flow rate, the times in hour is equal to ml by hour. So I have here one questions, because the board is not so good, so I prefer this paper. So I made you a question here. Mr. Smith is prescribed 1000 ml normal saline over 6 hours. A pump is available to administer the fluid. Calculate how many ml per hour to set the pump. So the question said we need ml per hour. So we are looking for ml per hour. Then we need to do prescribed is 1000 ml. So required volume is 1000 ml, and the time is 6 hours. And what we need, it's already in hour, so we don't need to do anything. We have already here ml, so we don't need to do anything. We get our everything what we need. Required volume here, time here. Now we need to divide 1000 by 6 is equal to, if you are good in mind, just use your brain. If you are same like me, just use the calculator. We can use calculator, then you don't need to worry about it. Then the answer is 166.666. Then we will write 16.666. In the volumetry pump, we can't use the decimal, so we need to round in. Is already above 5, is already here 6, so we are rounding by 1, so it should be 167 ml 8, so it comes like 167 ml an hour. This is our last one. We have intravenous flow rate, drip drop rate. Now we are using the formula for drip drop rate. Before we use the formula for flow rates ml per hour, now we are using the formula for drip drop rate. So the formula is required volume. Required volume is always on top, and the below is the time, which in minutes. In the flow rates of ml hour, the time in hours, and drip drop rate, the time in minutes. So in 1 minute, in 1 hour, there is 60 minutes. So we need to required volume mLs by time into by drop factor. You need to remember this formula, drop factor. So we are going to do here, I have one question here. Mona is prescribed 1000 ml of normal saline over 12 hours. The drop factor on your tubing is 20. Calculate the flow rate in drop minute dpm. It already asks for us do the dpm. So we are using our formula. What's the required volume? Required volume is 1000 ml. And what's the time? Time is 12. So we need in minutes. So what we need to do? We need to into 60. When we multiply this one, we will get 720. So after that, we need to look for our drop factor. So we need to look our drop factor. Then here is right here. The drop factor in your tubing is 20. So we are putting here 20. Now we need to calculate 1000 into 20 and divide by 720. Let's see on calculator. If you are good in mind, just do with your mind. I'm bad, so I'm using my calculator. We are is 27.777. The answer is 2.777. So we are rounding by whole number because it is above than 5, and in the IV we can't use the decimal points, so that we are rounding. So we are rounding to 28 dpm. We are rounding whole number because it's above 5. If it is below 5, then we can't round it. So it is above 5, so we are rounding to 28.